best for this system to be solved? What is easiest to make your life easy to do? Substitution or elimination?
Elimination.
Substitution. Okay, I hear substitution, right? Okay. How many? Okay, how about let's raise our hands. How many says substitution? Just raise your hands. 1, 2, 3.
Oh yes, I.
4. Okay, this table. And how about that? How many say elimination?
Oh, that's right.
And how many I just don't want to raise their hand? Okay. Okay, so you say substitution. Okay, cause us to like believe you why we would want to do a substitution. Why would we want to do a substitution?
This is just kind of what this is like. I kind of observed when we were like doing the guide notes. You know, you did substitution when you didn't have that like first like x value. You know, and then you did elimination when you had the 2x values. So that's just like my personal
That's your
observation.
It kind of be more easier with the steps.
You can't, yeah.
Okay, now let's go to those that want to do elimination. Why do you want to do it in elimination? You're try to make her believe why she would do it your way. Okay, go ahead.
Because for y, there's a plus sign and a minus sign, so it can easily cancel.
They don't want you up.
Blake, did you hear what she just said? She said this would be very easy to do it by the method of elimination because, as you can see, she said, okay, the x columns are lined up, the y columns are lined up, and the values are lined up, right? That's usually how elimination systems are set up for. Then furthermore, she said that, as you can see, the signs, like if you wanted to eliminate the y, she said the signs are opposite, right? You have one that's positive and you have one that's negative, right? And the coefficient in front of them are the same. So if you see those observations, of course, this would be easy to do it by elimination. And I'm not saying you can't do it substitution, but I think the easiest way would be just to get rid of the y column, right? Like what she just said, by adding them, and you'll have 3x. Right? You add them, you get 3x is equal to 9. You see how the y column just got disappeared just like that?
It's easier.
Yeah. Okay. Okay, now the second system, what I actually want you to do is write it on a piece of paper, right? I want you to write it on a piece of paper. If you can't read it, I'll read it for you. The first equation is y. Are you ready? Are you writing it down? Okay, y minus 3x is equal to 11.
You're going too fast.
Okay.
Just kidding.
Are you ready now? Okay. The first equation is y minus 3x is equal to 11. And the second equation is 2y minus x is equal to 2. So, first of all, just do that individually. You choose a method. You want to do a substitution? You want to do elimination? You choose by yourself and do it.
I think elimination.
Okay. And I'm not asking you to do it until you get an ordered pair. I'm asking you to do it until you come to a point where you eliminated one of the variables, okay? Then after you do that, we'll have you get up and go to somebody and discuss your method. Okay, so go ahead.
So before you guys talk about the blue system and the red system, did you change your mind after hearing what Anna said about elimination? So you now see that you can eliminate?
Okay, then, so then...
Doesn't mean substitution is wrong, it just means elimination is also a possibility?
And it's faster too.
Let's say that the problem was
Potentially, yeah.
Let's say the problem was substitution and elimination.
Are we gonna have
How we pick, like, if they're both that way, like one?
Yeah, in certain situations you get to pick. You could use elimination or substitution on just about any system. And you kind of get to choose which way you want to do it.
How can we learn to like this? But how can we learn? Is there gonna be like a guided notes that's gonna like show us so that we can like use both?
I think during this lesson he's going to show an example of where you could use both. In fact, I think there's going to be, at least last hour, there were students that looked at this new blue one that you're looking at right now, and a lot of them wanted to use substitution and a lot of them wanted to use elimination. And I think he's going to show that they're both an option.
Is this right though? Like, what? This
So
part.
you added those two equations together,
Yeah.
right? I gotta get this to focus a little bit more.
What if it's wrong? It's gonna be so embarrassing. Like,
So
no.
I don't think there's anything wrong about what you did.
Okay.
But did you get one of the variables to disappear, or do you still have two variables in your equation?
No, he just said like don't get it to like the ordered pairs. Like I was just like wondering.
No,
Get it to one,
but what
get
he,
to like
what
this
he
one's
wants is
gone,
he
like
wants
that one.
you to get to an equation where there's only one variable left. There's not still an x and a y. There's either just a y or just an x.
Wait, like on the same side or just like?
So, Simone, you decided to take the top equation and solve it for y and then substitute into the bottom equation, it looks like, right? And now you've got one equation with just the letter x in it, and you're starting to distribute and all that stuff.
Okay, I give you guys time to talk already. Okay.
I need more.
So the second system that I have.
With your hand maybe.
What you should like.
Bobby, can I see you now? Okay. So the second system that I.
Like this solution.
John and can I see it now? Can I get a little bit? Okay. So the second system that I have you guys work on, which method did you guys choose? Elimination. So, is there anybody that chose substitution?
We did? Yeah, we did.
Oh, you guys did? Okay. I actually, that's good. I know most of you chose elimination because this whole week we've been doing elimination. But this one, let's actually do it by substitution to just review for the quiz that's coming up, and we haven't done substitution in a while, right? So, how did you guys, those of you that did it in substitution, how did you guys do it? What did you guys do? Okay, Maurice, what did you do?
I eliminated the y. I eliminated y.
So are you doing elimination or substitution?
Substitution.
Okay, so I should not hear elimination.
Wait. Pick on. Yeah, her.
Okay, did you say something?
No.
Okay. So who else did substitution? Can I? Okay, what did you do?
Oh.
You want to tell me something tomorrow?
What?
What did you do?
I subtracted 3x from the top equation and added to the other side.
Okay, that's perfect. So what she did is she first observed these two equations, right? She saw that the bottom one wouldn't be really easy to solve for any of them. But she said, oh, the top one I could solve. The top one for y very easy is I could just add 3x over, right? So when she did that, she got y being equal to 3x plus 11, right? Right? Then after that, I'll just rewrite that here again. 2y minus x is equal to 2. After she solved for the first equation, then all she had to do was substitute, right? So where did you substitute? The next question is, where should I substitute that?
I did distributive property, like I put 2 in parentheses 3x plus 11.
Okay, so she said she put 2, then she put a parentheses, then you put, what did you say after that?
3x plus 11.
3x plus 11. Yeah, go ahead, keep telling me what you did.
Minus x plus 2 equals 2.
Okay, do you see where she substituted that? Do you see where she substituted the y?
Yeah, I do.
You do? Where did she substitute the y? Do you guys see where she substituted the y?
Yeah, I just picked the number.
Okay, so she took y is equal to that, right? So she took that and she just said, since y is equal to that, I could just replace this y with what y is equal to. That's what she did. That's what she substituted. Then after that, she says she distributed. So when she distributed, she got, what is 2 times 3? 6x plus 2 times 11 is 22 minus x is equal to 2, right? Then you solve for x, right? Okay, you can subtract 22. Then you have 6x minus x is equal to negative what? How did you get negative 11?
I got negative 1, 3. No, I got x equals 3.
Negative 20, because 2 plus negative 22 is negative 20. Then what do we do next?
See, I got that.
Yeah, combine like terms.
Yes.
So 6 plus, there's an invisible 1 here. I mean, minus an invisible 1 here.
It's negative 1.
It'd be 5x is equal to negative 20.
No, because we did it right.
Then when you divide by 5, you have x is equal to negative 4.
I got positive 4. Negative 4.
Right?
I got positive 4.
Then, what did you got positive 4?
Yeah, okay, because we're, me and Kristen, did it the same way, but, now I don't, the substitute, I'm, doing the substitution what you do in the guide notes, but, I don't know, can you see,
So looking at this work, did you do elimination or substitution?
Substitution.
So looking at this, do you see anywhere where you have made error?
We got positive 4 instead of negative.
She didn't put.
Well, no, because it wasn't a negative.
It's negative 22.
So do you see anywhere here there's an error, maybe
Because see, that's a
in my
positive,
sign?
so change to negative.
No, it's what?
Negative. You put.
Well, no, it all has to
Okay,
do
how
with
about you talk to me after class, let's look at your work.
I don't know.
Anyway,
There's lunch,
man.
So we got our x to be negative 4, right? How do we determine our y value?
Good morning, teacher.
Yeah, we just plug it in or we substitute again. Where do we substitute? Yeah, we substitute for x because x is equal to negative 4. So we can do it either here or here, just wherever is easier. Right? So we could take this x and put it in here, right? So we get y is equal to 3 times what? X is negative 4 now. Then that's plus 11, right? So when you simplify that, what is y equal to? What is 3 times negative 4? Yep, negative 12. And plus 11? What is negative 12 plus 11? It's negative 1. So our ordered pair is what? Negative 4 and negative 1. So we only have 6 minutes, right? There is one last system up here which you could, it's like an exit ticket, right? You take that, choose whatever method you want to do, substitution, elimination, solve it, show me, then you could go to lunch.